Done. So let me give you an overview of this game. So let's see it here, how it is. So here, if you can see this, so this is the task, design tic-tac-toe. And by designing we mean, again I'll reiterate, object oriented design. Okay, that's what we also call it, the low level design. Okay, so before beginning to solve any problem, first of all we should know what are we going to solve, what is it all about, what is the person who is taking interview, or who, or the product manager, if you're working in a company, if he is coming to you, then what does he want to build or make. Okay, then we define the requirements. That's what is called requirement gathering or requirement specification. Okay, so let's narrow down and talk about the game first, and then we'll go about the requirements. First of all, what is the problem statement? Okay, so what is tic-tac-toe? Tic-tac-toe is a two-player game played on a 3 by 3 board. Each player is allotted a symbol, one X and one O. Initially the board is empty. Alternatively, each player takes a turn and puts the symbol at an empty slot. The first player to get the symbol over a complete row or a column, or a complete column or a diagonal, wins. So I hope many of you must have played this game. Okay, and you can also play this game by typing it in the Google search tic-tac-toe. Let me show you. If you type tic tic-tac-toe here, you can see here. Okay, so if I do an X here, the computer plays, and if I do an X here, the computer plays, and if I do an X here, the computer plays, and I can do, and then this is a game. I hope most of you must have played this game. So with the understanding clear, this is the problem that we are going to solve. Let's go ahead and discuss about the requirements. What would be the requirements for designing this? So now the example that we saw here was of a 3 by 3 board, but we can also have a n by n board. Okay, so that's the requirement. So why do we have requirements? I hope you understand that. So either we are building a product or in an interview, so we should know what are we. So by understanding the requirements, that's how we know what are we going to build. And this is where you clarify, if you're going for an interview or even if you're working, you clarify here and try to understand the breadth of the problem. And then when you narrow down, means either with respect to the company, when you narrow down about what will be the MVP that we are going to build in a limited period of time. And similarly, when we are doing an interview, we narrow down the scope of the interview, because we have a very limited time. Generally it's 1 hour, and if you cut 15 minutes out of it for the discussion and everything, it will be like 45 minutes for coming up with a design. And in some cases you have machine coding round, where you will have generally 1 hour 30 minutes time, where you will be expected to code too. So even the coding will take time. So that's it. So let's try to finish this thing within 45 minutes till we do the class diagram. So that's the thing. So let's go ahead with the requirements again. So the board can be of n by n size. Okay, there can be 2 or more players. We can have either, as you saw on the Google search window, right, there was only 1 player. We can have 2 players also. The other player was a bot, so there were 2 players. So that's the minimum requirement for playing it. So other player was the bot who was playing on Google's behalf or the browser's behalf, right? And the second player was me. And then we can also have multiple players playing, and all of them can have different symbols. So here and if you see, that's each n-1 player will be allotted a different symbol. That's the next requirement. So you know there will be X, O, we can have triangles, we can have squares, depending upon the number of players. So here is the example. Then again we talked about the players can be either humans or bots, and then each player will have a name, email, and profile image. So when you play a game, right, you can create a user profile, and then general user profile have as a name and email and a profile image. So one player can create his profile, and these things will be there for the profile or the user. Okay, and each bot player will have a difficulty level. So whenever you might have played many games, so each game will have difficulty levels. So similarly for this, for when the computer is playing against you, or when you are playing against the computer, so you will have difficulty levels. So that is one of the requirements. And for starting the game, any random player can start the game. Either here I started, or if there are multiple players, right, so randomly you do a toss, or you do okay, which player will start the game. So that will be a random thing. And then once that is decided, we will have sequence of users, which will be there, and they will take turns sequentially, and they will keep on playing in the same order throughout the game until the complete board is full or we have a winner. Okay. And the next requirement is the player with any consecutive n symbols in a row, column, or a diagonal wins. So that's the rule of the game. And if the board is full and no player has won, the game is draw. So you know the rules. And then we also need to have a provision for undo. So if you understand it this way, so sometimes there may be provision that a player wanted to make a mark somewhere else, places piece somewhere else, but he accidentally put the piece somewhere else, so he wants to undo the game. So that's where this undo thing comes. So we'll also see if we can implement it. We'll talk about how do we do the undo, and then we can have extra requirements too. If you talk to the product manager or the interviewer, you can ask him what are the more behaviors that he wants to have. So there can be like tournaments, like multiplayer tournaments, and if you want to save the information for all the games played, then you can have a leaderboard historically, how each player, how many times he has won, and for each game what points he got. And for that from that historical information, if you persist that in a database, you can have a leaderboard. Okay. And you can, the third would be like replay moves or rewatch game. So if you see in chess, right, you can this is a similar board game. So when you, sometimes we want to see, okay, what moves the other person made so that he won the game, so you want to replay that and understand the game. So for that purpose, even in this game, we can have this provision. And the other provision would be like pause and resume the game. So if the players are away, they can pause or resume the game. And we can have one more requirement, like we can set a timer that if the other person doesn't uh, make the move or place his symbol in that particular given time, that person loses or is out of the game. Also, we need to, when there are like more than one player in this in this game, right? So we need to define how the player wins. Okay. So now before proceeding with the rest of the thing, so if you understand, there are like two types of things. First would be, there will be entities in the object oriented language, like entities or the objects that will be interacting, and each entity will have some behavior here. Okay. So we need to take each one of them separately. We can either have the okay. So we can have entities or behaviors. Entities will be the objects and the behaviors will be the behaviors of those entities. So here, if we go, and how do we proceed with this game, how do we go about it? So if you see each of the lines, when you go about through the requirements, right, either when you see it, look at the problem, you can see what are the objects that to be like jumping out of the screen. I was talking about the entities or nouns or objects in the OOP principle. So there may be, I will make another video where I'll be talking about the OOP principle. Okay, why do we model, how do we model, and before as in my other videos, right, why do we model everything in the object oriented way, what are the advantages, and why is this object oriented way so famous? I'll make another video for that. So let's proceed. So if you see this thing, so first of all, what entity you can see is that you will have a game. So that's what we are playing here, right? So it's all about, it begins with the first thing that should strike you as soon as you see this is like that it's a game. So that will be our first, that's the overarching big entity or object which will have other entities within this. So that's our big entity because we are playing game, and it will have most of the behaviors. So all the rules for the games that we saw, any game that will have, it will become its behaviors, and those behaviors, what we call in object oriented way, we call them methods or functions, whatever. Mostly we call it methods, so let's go with that. Okay, so that's the first thing which you can see. So when you play a game, so you see a game. Okay, what's the next thing? So next thing, if you mm, if you remember, so you saw there was a board, right? So this is a board that you saw, and then you were placing all symbols here. Okay, so the next entity which comes obviously out of from the requirement is that it will be a board. The game has a board, so you go from outwards and then you focus in. That's how we perceive the world also. You get the bigger picture first, and then the bigger picture is, okay, it's a game. Now within the game, what kind of game it is? Okay, it's a board game, so next thing will be obviously it's a board game. Okay, there is a board. Okay, and then within the board, what do you see? So next thing, what you saw, that there, what are in this board, there must be somebody is interacting with this board, right? Somebody is playing with this board, so there will be players. There can be multiple players here, or there can be one, can be a player one, and other can be bot also, as we saw in the Google example here. Okay, on the Google search we saw. So this will be the computer playing against us. So there can be two players. So similarly we can have so these are the players. So next thing will be players, and each player will have symbols, as you saw, right? Symbols. And then what else can you see here? So we have players, we have bots, we have symbols, and then again we focus down. So within players we will have different types. We'll go in detail there. So players can be players, and their players can be like human players, and they can be bot players too, bots too. Okay, and then what else can you see? So if you see this board, whatever you are seeing, right? So this board is nothing but a matrix, right? Do you see? Let me extend this here. Okay, and this will be extended here. It's a multiplayer environment, so if you extend it here, and there can be multiple players playing here. Okay, so somebody can say, so how many are there? So if you see 1 2 3 4 5 6, and then 1 2 3 4 5 6. Okay, let's remove this one, and then remove this two, and this will be our sixth one. Okay, so let's say this is 6 by 6 mode, including the upper one. Okay, so we can have 6 symbols, means we can have, like, if it's a n cross n board, then we can have n minus 1 players, right? So for example, this was like a 3 cross 3 board. You see, this was a 3 cross 3 board, then we had 2 players. So if it's n cross n board, then we'll have n minus 1 players, and each player will have, then we'll have n minus 1 symbols. For each player there will be one symbol. I hope you get this point. Similarly, we can have, as you saw, right, we can have X, we can have O, we can have another symbols. Each one can choose their symbol. We can have a square, we can have a triangle, somebody can have a star. So each player will, when they come in, they can register their symbol, and then that's what it is. So this is, so if you see what I was trying to make is, if you see this thing, right, this is a nothing but a n cross n matrix, right? It can be, and each matrix will have this box. If you see this, how, if you go about this, right, how do we represent? So if this is my thing, right, how do I represent this? This will be by row comma column. It's like if I go by 1 2 3 numbering, so this will be like third row and fifth column, I haven't taken the zero based numbering, but it's simpler to understand 1 2. So this is how we represent. And what can we call this? This can be called this can be called a cell in this matrix, right? Cell of a matrix, right? I'll remove this to avoid confusion. So you see, this is a cell now, and this cell will have what? Rows and columns. Also we'll have a player information there, that when we go about designing it. So but you get the point. So these are the things. So if you go one by one, so revise, we have a game within the game we have a board, and there are other entities which is player, and the board will have cells. So these are the things which we can see obviously, which come out. These are the entities. Okay, and when we go ahead further, and we'll see that what are the relations. So these are the entities. So these were the entities that we had, and for each level, so now we will define the behaviors that we want to see. So if you see the game entity, so within a game, what kind of behaviors do you see? So before going into behaviors, let's narrow down our entity relation. Okay, so first would be game. Game is made up of board. It is made up of players, obviously, list of players. Then what else we have here? The game will have board and players first of all, and then we'll have more methods. So this is one thing. Then the two, board will have cells, a list of cells. 3, then there will be players. Players will have what? Name, email, profile picture. Okay, then there will be cells. Cells will have row information, column information, and the player information. What player is there in this cell, so that we can keep a track of it. I hope you get this point. So this is how we narrow down. So we have a game, and within a game we have a board, and then within a board we have cells, and then we have the players. And within players we can have multiple types of players. There will be like human player, and then we have the bot player. So this is our entity relation here. And whenever you see like, so one game, so if you see the relation, if you go by, if you want to understand the cardinality, right? So I'll write the cardinality below. So I'll explain you one cardinality here at the side. How do you define cardinality? Means how do you understand? So if you see, there's like, if you write board here, and if you write, sorry, I'll write opposite. You have a game and you have a board. So in one game you have one board, right? And each board will be part of one game. So if you see, so both the ways it's like 1:1. So this is how we find the cardinality. Now if you see with respect to, now it will take players, game and players. So one game can have many players, right? And one player will be at a time part of one game only. One player cannot play multiple games at a time. That's how we understand. So you can say that, okay, why can't one player play many games at a time? But during one session he can open many sessions, and but those will be different games. But within a context of one game, one player can play only one game. So this is because our underlying the overarching thing is the game. So within one game we can have only one player can be part of one game. So here you see there's one n and then one n. So now you see that one player, this is 1:1 cardinality. Okay, so similar thing, I'm giving you these examples. So when we do the class diagram, right, and when we're building the class diagram in detail, I'll show you then. that we will be considering these cardinalities too, and this is our entity relation. So when we do DB models, right, so that time this cardinality is used. So when it's like 1:1 relationship, then you can put this information of one in the other as anything. You can, it can come as a foreign key. And when it's like 1:n relationship, so the information of the one uh, comes on the n side in the DB. Okay, and similarly if it's like many is to many, so if it is like m:n, right, then we have a mapping table where we map, okay, the m side and n side, and there will be id of m and id of n here, which m belongs to which n. So this way we do it. So this is a general principle for this, is like entity relation. What is the relationship, and then what is the cardinality? This will be like relationship and cardinality. Both of them together constitute entity relationship. We create diagrams also, and that's called ARD. That's respect to the DB, but I will not go in detail further here. Now let's come back to the class diagram here. So I'll show you the class diagram. I'll use a tool called Mermaid for doing the class diagram here. So I have already the class diagram present here, but I hope you get this breakdown here. How are we breaking these things down? Okay, and I have the class diagram ready. I'll walk you through this so that we can go through that together. And let's also confirm that whatever the requirements we came up with here, or whatever the entities we came up with here, right, does this add up with whatever we created? Let's come back. Okay, so these are the requirements, extra requirements we talked about. And now if you see here, right, we have the game, and as you saw, right, we came up with the game had boards and then it had players. Now if you go to the board, it had cells. As we discussed, cell will have row, column, and here I have put symbol, but we can have the symbol of the player. It's easier to go anyway. Then we have the human player. It will have a name, email, and profile image, which was in the requirement itself. And the bot player will have a difficulty level. So I discussed about it, but I didn't mention it. Okay, now let's go to the class diagram here. So this is here, it's a bit difficult to see. I'll take you through this thing. So here, this is the tool Mermaid, okay, tool, and here we can create a class diagram, and this is what you are seeing it here. So now you can just write class diagram, and then you have the class game. It's a good tool. I would recommend you to use this. So we have a class game which has a one board. It has a list of players. Okay, then again, as we discussed about the behaviors, right, so it will have a winning strategy. So when we do talk about class diagrams, right, so there I'll show you there are expectations here. What should be the code should be working and functionally correct. There good software design practices should be followed. Okay, so good software design practices would be like the design patterns that I have taken few classes already. There are some other videos for the design patterns that we have. So what design patterns we will use so that our design becomes modular, readable, extensible. Okay, that's what it is. That's why we use design, best design practices. Also we will follow the solid principles and the dry principles so that our code becomes very standard and it's like extensible and it's easy to modify. Anybody can read and everybody understands this code easily. Okay, and there's a separation of concern should be addressed. This is like the single responsibility principle. And the project structure, so project structure also I'll talk about the MVC framework in a very brief way. We should also write unit tests and CLI app, which we don't need a GUI. This is with respect to the machine coding round when we do. So this is the expectation. So think whatever we can cover in 1 hour 30 minutes during the machine coding round. But once you are through with the design, right, and once you have the class diagram, writing the code becomes pretty easy. I'll show you how. So these are the expectations. So with that in mind, so if you see here, what kind of design patterns can be used? Okay, so let's come back to the design class diagram. Okay, so if you see at the class game, it has board, it has players, then we should define the behaviors, right? So for that, you must be aware of strategy design pattern. So for that, we'll have the winning strategy as the member, and depending upon what kind of strategy we use, that kind of method will be called. Similarly, with respect to game state, so what will be the current state of the game? We should be able to save that also. We can keep that as enumeration, and what's the if the game is in progress or it has been drawn, if all the moves have been all the cells are full, right? After that, we can declare it as draw, and then if we get a winner, so that time the game status will be winner and we can exit from the game there. Also we can so if you that was for the game state. Now start game. So there was a requirement to start the game, right? How do we start the game? So randomly a player will be chosen. That was the so we need to implement this. So that will come when we do the actual implementation. But when we are doing design, we will know, we'll have the wrapper or the structure ready for what all methods we need to implement, and the algorithms what will be coming within that can be done later. But before that, we have to build the whole class diagram. That is what it is useful. So this is you see how it makes our life easy. You will know what all methods are going to be. The algorithms can be then again given to developers who are like mm, new to the company, or the juniors. You can just tell them, give them the pseudocode. This is what the algorithm that you need to implement, and they can write the algorithm. But you need to give them this structure and define the algorithm for that, and then whatever language your company uses or wherever, they can write this algorithm within that. But that's not the scope of LLD. That will be covered in like as part of data structure and algorithm. But as a part of LLD low level design, we will only give the methods that will be that should be a part of the class. That's what we define. So this is the start game, and we make move. So this is very important, make move. So every player will make a move, and that will be a part of the game. It will not be part of the player, if you understand. So game is a part of making moves because all the players are part of the game, and all the players are supposed to make move. Okay, so making a move will be part of the game, and each we will have parameters. So you can define that player ID will be there, and int is for like which row and which column. So which player ID is making a move to which row and column. So this will be the signature of this method, and later on we can implement this method. Similarly, check winner. So we can you saw here, right? So winning strategy. So this check winner can delegate after every move. We can check, right, whether we have a winner or not. And for checking that winner, we can have this winning strategy. We can define what winning strategy we can have. Like we can have like if all the rows are full, or are full with the same symbol. If you have consecutive n rows with the same symbol, or n columns with the same symbol, or n it's diagonal, all the diagonals are full with the same symbol of a player. Okay, then we can declare it a winner. So for that purpose, we have this check winner. And before beginning the game, the players should be able to register themselves, and this is the time when they pick the symbols. And during registering the players, we will make sure that no two players are assigned the same symbol. So again, you see here that algorithm part comes here. So we define the method and algorithm that implementation entails. We leave it for the later part. Okay, this is our first. This is a major class, game class. Now if you see, this is you define the class game state, which will have, we talked about this. Then we have the class board, this one, which has cells, which has a list of cells. And the board, this is a constructor of the board, which will initialize the board with this n into n cell. So we give the integer size with the n, and it will initialize a matrix, n by n matrix, and it will keep all the cells as empty initially. So that's what this is. This is for constructing the board when we are using the client code to construct the board, right? And this will be made up of cells. Next thing, what does a cell have? So I have changed it here. So a cell will have a row, a column, and a player. So a player for keeping the information which player is in this row and column, or this cell particularly. And then we check whether we have a winner or not. And from that, from the player, we can get all the information. We can get the symbol and all everything. So that's why we keep the player information. Now we're coming back to the symbol. Symbol can have a name and an image. So we can keep like a X, we can keep as a cross, and we can have an image, and that will be an arrow bytes. Okay, similarly we can have a class player now. So we follow all those good principles, right, design principles. And we can have a abstract class. We can abstract out and we can implement different kinds of players out of it. So each player will have, so this will, we cannot instantiate this, this will be abstract class. We'll define it here, and it will have a symbol, and it will have a board cell where it starts. Okay, then we will have a class user. So a user which will have name, email. So this is for creating the profile. So profile, image, and name. So every user can register, and whenever the registered users can use the name and email to play the game. So you understand, right? Every time you come everywhere on any platform, game platform, your name or email is used as your username, and or you can have a field called username also, and then the profile image is shown when you are playing the game. So this is for that purpose. Now coming back to this important bot player. So in the bot player, we'll have the difficulty level, easy, medium, and hard, and the move strategy. So depending upon the difficulty of this, right? So when it's easy, then it will just make random moves. And when it's medium, it will make some strategic moves, and when it's difficult, it will make like really, it will have a very good algorithm so that nobody can beat it. So there, each algorithm. So you will have different algorithms or different strategies for different levels. So that's from this you can guess the name, right? So we'll be using strategy design pattern extensively. So just keep one simple thing in mind. So whenever you have different algorithms for the same behavior to be implemented, use strategy design pattern. I'll make a video strategy design pattern sometime later. And similarly for the where it is playing. Now move strategy. Now all the strategies are coming in here. So whatever strategy was a part of it, right? So move strategy, here we will have a class move strategy. It will have just it's an interface which will have only one method, make move, which will have the current status of the board and what board cell it's going to move to. Okay, what's the current status and which board cell it's going to move, where it's going to move. So when the this is with respect to the bot. So I have created 3 strategies for it: easy move strategy, medium move strategy, and hard move strategy. All of the 3 are different algorithms what I told, right? We will be discussing about that. When somebody can implement that, we need to write that algorithm. And these things are now the relationships. Now if you see, right, there's like the class game 1, and if you see the star, right, this is composition. So game class is composed of player. So why composition? Because the once the players are playing the game, so as long as the game is there, only then the player exists. Without the because all the players have registered to the game, so without the game the players won't exist. So you understand the composition rule. So if the parent entity dies, means it's not there, so this should also die, or it should be eliminated or deleted, because it doesn't have an independent existence without this. A simple example would be like a home with rooms. So if you destroy the home, all the rooms should also be deleted, right? So a home is composed of rooms. So there are 2 types of associations. This is a composition or aggregation. In case of aggregation, the entity can stand alone. So we'll see about that also without the parent entity. So next thing you see, right, game has a game state. So now here you see, right, this is a O, which is like a association. So we can have game states. Many games can have the same state, so it's shared between many games when there are like multiple games going on. So they can use the same state, so it's independent. Either the game is there or not, the game state can exist without the game. I hope you get the point. I talked about this too. One game will be composed of one board. If the game is destroyed, the board is destroyed. Similarly, one board will have many cells. So, and this is also composition. If the board is destroyed, all the cells should be destroyed, because all the cells were created when the board came up. You saw in the constructor we passed that value n, right? And that n by n matrix is created, which will be all the cells. And the cell, it is composed of a player. We saw that each cell will have a player information. It is association. So if you see that cell and players can exist independently, even if the cell is destroyed, we need not destroy the player, and this player will have a symbol. So even each player can, every time they register and they choose a symbol, right? So the player is not tightly coupled with the symbol. Each time a player can choose a different symbol, and many players playing in different games can choose the same symbol. So even the player is deleted, there's no need to delete the symbol. So it's an association. So I have to get the point there. Similarly, if we continue, right, so there's a winning strategy. So we can have a check winner, and n in a row. So you saw this is also interface for the winning strategy. This is a strategy design pattern, and each of the methods implementing this winning strategy, these are n in a row winning strategy, n in a column, and n in a diagonal winning strategy. So either we have all rows or columns or all diagonals, we can declare a winner. I'll show you it in the full class. I'll show you the full class diagram here. This is the final thing. So if you see, this is the game class. We have the board here, okay, and then we have all the associations. See this winning strategy, all these inheritances, you saw all them from the winning strategy. All this are inheriting from the winning strategy. So I'll share this code so that you can open it in Mermaid live. I'll share this link too, and you can check it out yourself.